Okay, so our second part of our video is going to focus on solving systems of equations. And our first question, it says to solve the system of equations by graphing, then verify the solution that we find. So let's go ahead and start off by graphing each one of these equations. These are both in slope and intercept form, so they're pretty easy to graph just by looking at them. We're going to start off with y-intercept of 3, and then go up 2, and then to the right 3, up 2, right 3, up 2, right 3. You can also go down 2 and left 3, down 2 and left 3. All right, so that gives us y equals 2x over 3. And we're also going to graph this line here, where we have a y-intercept at 11 and a slope that says down 2 over 1, down 2 over 1, down 2 over 1. As you can see here that they intersect right there at that point when x is 3, y is 5. Now I want to verify my solution by plugging this point back into both of these equations here. So I'm going to go ahead and do that and then show you if it's true or not. I plugged in the point into x and y into both equations, and I've found that I get a true statement, which means that yes, the point is on both of these lines. We've verified the solution we've solved by graphing. Let's go ahead and move on to the next question. Okay, so for our next system question, we have to solve the system by substitution and graphing. The first thing I'm going to do is substitute one equation into the other. I see that I have this equation equals y minus 1/4 x plus y is equal to 1. So I'm going to substitute that into that other equation here. Let's go ahead and pause, and I'll do that, and we'll see what happens. Okay, so I've substituted one equation into the other, and now I have an equation that only has x in it. I'm going to try and solve for x. First, by distributing 8. So I distribute the 8 to first term negative 1/4 x, and I have an 8 over a 4, which is a 2. So that gives me a minus 2x. And then 8 times 5 is 40, and then plus 2x equals minus 16. So I see that I have these two terms on the right side of my left side of my equation, and I'm going to combine them. Minus 2x plus 2x is 0. And so that's odd because we cancel these off and we end up with this equation that doesn't have x in it. We have 40 equals 6 minus 16, which doesn't make any sense. I'm like, how can that be possible? Well, there's really no solution on this one because these two lines are parallel to each other. Well, what that means is these two lines are never going to cross. Let's go ahead and solve our bottom equation here for y, and then graph both equations to see visually what's going on. Okay, so solving this bottom equation for y, I'm going to subtract 2x to both sides. And that's going to give me 8y equals minus 2x minus 16. Then I need y all by itself, dividing each term by 8. So that gives me y equals 2 over 8. They're both divisible by 2. And that's going to give me a 1/4 x and then minus 2. So we have these two equations that we can graph. I can see that both of them have the same slope, which means they're parallel. They're never going to cross. Let's go ahead and get the visual on the graph. All right, so we got parallel lines, never going to cross. We're never going to come up with a solution that makes any sense when we solve. All right, let's move to the next one. Okay, so for our next question, we need to solve a system of equations by elimination and graphing. So I want to add straight down and cross off either the x term or the y term. And I can't do that right now. I need the coefficients to match with different signs in order to cross off. So I can see here that I can make a negative 2 into, I can make a 2 into a 4 pretty easily just by multiplying this equation by a 2. So that's going to give me, I have 5 is 4x plus 2y equals 10. In the bottom now we multiply by a positive 2, minus 4x, 12y equals minus 24. Now when we add straight down, 4x crosses off with 4x, and we have a 14y equals minus 14. So if we divide by 14 on both sides, we end up with y equals a negative 1. So if I plug this negative 1 back into either one of these two equations, we'll be able to solve for it. Plug back into the top original. And we have 4x plus 2 times minus 1 equals 10. And then we have 4x minus 2 equals 10. Add 2 to both sides. We have 4x equals 12. And that means that x equals 3. We have a point of intersection. X is equal to 3. Y is equal to a negative 1. That's the point right here. I'm going to go ahead and solve both of these equations for y and graph them and keep my fingers crossed that we will go through that point there. So I'm going to put it on pause. Okay, so after graphing the two equations, I can see that the two lines do intersect at the point x is 3, y is negative 1. And remember that we solved for y so that we could graph the lines in slope-intercept form. Identify the intercept, identify the slope, and use those to create the line. And let's move to the last one of the bunch. Okay, so for the last one, we once again have to solve the system of equations and graph and explain the solution. So I'm going to do this by elimination, and I can see here that I can't make a 5 into a 2 or a 2 into a 5. I want these coefficients to be the same with a different sign. I'm going to multiply the top equation by a 5 and the bottom equation by a 2 so that I can cross off the term with the x. So let's see what happens here. Got a 10x plus 40y equals 30. And then we got a minus 10x minus 40y equals minus 30. And if I add straight down 0 equals 0, which is kind of peculiar because we don't normally get that, but actually we have a situation where we have the same exact line. We cross off each other completely because it's literally the same exact line. Gotcha. And so if we were to graph both of these lines, we would end up with one line on top of the other. And what that means is that we have infinitely many solutions. Let me go ahead and solve both of these equations for y. So we have infinitely many solutions because we literally have one line on top of each other. They're constantly intersecting. There's one more thing I'd like to point out. That at our start here, if I were to divide this equation by a 2, I would end up with x plus 4y equals 3. And if I were to divide this one by a 5, I see each term is divisible by 5 here. I could divide by a 5. I would end up with minus x minus 4y equals a minus 3. And we can see here that they're almost the same equation. If I were to multiply the bottom by a negative, we would have the same exact equation. And we can clearly see that one line will be right on top of the other. Coinciding lines is what we call this.